Today we're factoring and graphing part 2. So anyone get the lights for me, please? All right, this is called a double bubble. Let's compare and contrast these two. So just for the next 30 seconds, talk in your group about things that they are similar, and things that they have that are different, comparing and contrasting. Go. Okay, what'd you guys come up with? They're the same? Okay, well, let's see. I could either multiply this one, so I have an x times an x is x squared, and then I have a 2 times a 1, which is positive 2. And then in order to get my middle term, I have to multiply the inners, which is 2x, and the outers, which is positive x. So it's x squared plus 3x plus 2. So they are the same. Or I could have factored this one, right? What do I know? So basically they are the same equation. They are the same, I guess you should say, same graph. They're the same graph, but they're not the same equation. This, right here, I shouldn't say equation, expression. This is an expression with 3 terms. This one has 3 terms. This is an expression with factors. Right? So this is factored. It's just like having, this would be a good example, the number 12. This would be the number 12, that's an expression, right? Or 3 times 4. These are factors, this one's not. Okay, that's kind of what we're dealing with here. What factors give us are what? What do factors give us? It's a simple, but why? Why do we turn it into factors? Why even do that? What do they give us? What do these factors give us? The distance apart from x, so to be specific, gives us zeros of the graph, right? It gives us our x-intercept. What does this one give us? Here. It gives us our y-intercept. So they both are the same graph, but they give us different, if they're in different forms, they give us different pieces of information about the graph, right? This one gives us our y-intercept. This one gives us our zeros. Okay? Let's move on with this. All right, whiteboards. Get some whiteboards out. Factor this one for me. Okay, don't erase. I kind of looked. So I see a lot of people using this method, which I reminded myself of this morning. So let's just talk about just in terms of coefficients. This is a 1 and this is a 24. I need it quiet, please. This is a 1 and this is a 24. The reason, and this is what I'm trying to get to. So what two numbers, when we multiply I get 24, but when I add I get 10? 6 and 4. Those are your magic numbers right there. So I'm going to rewrite this as v squared plus 6v plus 4v plus 24. I just split 10v into 6 and 4v, right? Because that's what adds up to make 10, but when I multiply them I get 24. Then I'm going to factor this first one. I've got v times v plus 6, and then I've got, what do these two have in common? 4 and v plus 6. Now they match. They both have v plus 6's, so I'm going to factor out a v plus 6. When I factor out a v plus 6, it makes this one and this one go away, and so all I'm left with is v plus 4. Now, many of you, I saw, can go from this to this without even practically thinking about it. That's okay. It means you're good with the only reason that I'm doing this whole process right here is because today we're going to have a coefficient, and it's not going to be as easy. So this method right here is going to be much, so remember I've told you that before. It's all about structure. So if I teach you how to do something that to you seems way long and difficult because you can do it real quickly in your head, the reason I'm doing it with something easy is so that it can be easier when I do it with something that's a little bit more difficult. Okay? So for those of you that can go from this to this, I have no problem with you doing that. Okay? You don't need this middle step if you don't need it. All right. So let me get rid of this and here. You guys have that. Let's do another one. Yes? Go ahead and erase. You do that one for me. Okay, most importantly, we're at about 50%, you guys. We're at 50%. And I'm not really surprised because factoring always seems to be an issue. So for those of you, Tita, can you put the cap on that marker so it doesn't run out for me, please? Thank you. Anybody who doesn't have a cap on their marker, they should have a cap on their marker right now. Okay? That's why these markers are running out so fast. So it doesn't surprise me, but if you're bored, please just hang in there with me because we've got to get the if I've got 50% of the class that can't factor that properly, we've got an issue. I can't just move on, right? Okay. So bear with me. All right, so I'm just going to do the little V thing over here, or I guess it's next. So we're talking about factors. I've got 1 times negative 40 is negative 40, and I've got a negative 3. So I have to think about what two numbers, when I multiply and make negative 40, got bad static right now. That one for me. Okay, so I'm seeing a lot of you skipping that middle step, which is fine by me, but I'm seeing this. This is great. This is helping you out a little bit? Okay, so I've got a 1 times 16 is 16 and negative 8. So I know that 4 times 4 is 16, but I have to make both of them negative in order to make a negative 8. And you could have, at this point, I think you could have at this point said if they're both negative 4, this is actually a perfect square trinomial, right? So that means it has a double root. It skims the x-axis only one time, right? We know that about its graph. But I'm going to go ahead and go through the whole process like I have been with you for those of you. No, I hear no's in the back. Okay, so I have a squared minus 4a plus 16. I'm going to group these together, and they both have an a in common. So I'm going to take out an A, and then I have an A minus 4. These both have a 4, but whenever you have a negative sign, I need the talking to stop back there now. One of you come up here. You guys choose. So when you have a negative with it, and I see a negative here, usually I have to take that negative with me as well. So I'm going to pull out a negative 4, and I'm left with A. And in order to make negative 4 be positive 16, it's got to be also negative 4. And, you know, it just kind of gives us that idea here as well. So I've got A minus 4. When I factor that out, I'm left with an A minus 4. So normally we would write it as a double root. One more, or do you want to move on to the harder stuff? One more. I can do one more. No. They mean the same thing. As long as something on a Common Core test would be, Aaron, why is it called a double root? All right, guys, do that one. I think after this one, we're ready to go. All right, so I'm going to ask myself, get my little X out here, and all it is just organizing my factors. So I have negative 12 and negative 4. So what two numbers? I know 6 and 2 make 12. Does 6 and 2 somehow make negative 4? Yes, somehow it does. 6 and 2, I would have to make that 6 negative and the 2 positive in order to make it negative 4. So I'm going to go ahead and rewrite this. It's p squared. So instead of writing this, I write these two factors in place of it. So I have negative 6p plus 2p minus 12. So start my factoring. These two both have a p. So factor out a p, and I have p minus 6. And then over here, it's a positive 2, so I'm just going to say plus 2. Pull out a p, and that would be minus 6 as well. So I have, when I factor out a p minus 6 from both of these terms, I'm left with p plus 2. All right, I think we're ready. Let's move on. Can you take the test? All right, so students will be able to factor, identify the axis of symmetry, and the Y-intercept. We're doing all of these concepts again today. So if you were lost in one of those, good news, right? We're doing it all over again today. We're just, instead of having a coefficient of 1 with that squared term, it's going to have a coefficient of something larger than 1. Christopher, can I get you to take the hat off for me, please? Fantastic. Okay, pencils down. So just like we did on Friday, we're going to multiply first, and then we're going to go in the reverse. Okay? So I'm going to start with, I just want you guys to listen for me. I'm going to start with my first factors, my 2x and my x. 2x times x is 2x squared. Then I'm going to go to my last factors. Sorry, they're not factors. These are parts of my binomials. I have a negative 4 and a negative 2, which makes positive 8. And then I'm going to go to my middle. I have, remember my rainbows and checks? So negative 4 times x is negative 4x. 2x times negative 2 is negative 4x, to make a total of negative 8x. In this form, I can see what the zeros are. I can't really see what this 0 is because it's not talking about 1x. It's talking about the distance between 2 x's and 4. Well, if I know the distance between 2 x's and 4, how could I figure out only 1x? Divide it by 2. So, if I divide both of these by 2, I get, it's kind of like factoring out a 2 from it. I could do that as well. Let's rewrite it like that. That's the way I do it. I just divide it. I say, I don't want to know 2 x's. I just want to know 1x. So I just divide it in half, and I know that number's 2. Or, traditionally, you would factor 2 out of there. And you would get an x minus 2, an x minus 2. So what do I know about this particular graph? It's what? Right? It's a double root. It has the same root. So it's only going to touch it once, like Kane said. So it's going to touch the x-axis at positive 2. X minus 2 squared. That's what this is, right? 2 times x minus 2 squared. All right, so there's my only x-intercept. I know from putting it in this standard form that my y-intercept is 8, right? So I go up to 8. I know my axis of symmetry, because I only have 1, 0, my axis of symmetry is actually on that 0. So my axis of symmetry is x equals 2. And so then I know I also have symmetry on the other side of my y-intercept. If I'm over 2, I must be over 2 more. And that's all I need to graph this. I should do it in blue. That way you can see it. And it's not supposed to look like a V. It's supposed to look like a U shape, right? Even though it kind of looks like a V. It's not supposed to be an absolute value graph, okay? All right, how are we doing? Thumbs up, thumbs down. One more? I'm going to go real. You guys want to show this one to me on your whiteboard? Yes? Try this one. Just show me. I want the trinomial right here. Show me the trinomial. Okay, so almost everybody's got it. Oh. Okay, we'll go through that again. Perfect. Thank you for telling me, Bryce. Okay, so I'm going to start with the first one. There was only a couple of you. We got to multiply the first and the first. That's how we get the first term, by looking at our factors and multiplying the first part of each one of the binomials. So that's 3x squared. There's only a couple of you that weren't getting this part. Almost everybody's got the middle perfectly. This middle is positive 6x and negative 3x makes a total of positive 3x. And everybody's got the last. Multiplying the last term times, the last term in the binomial times the last term in each binomial makes a negative 6. Yes, Christopher? We're going to find our zeros. Okay? All right? So in order to find my zeros, I could divide this by 3. That's graphing it. This is just finding it in standard form. This is factored form. These are factors, and this is standard form. Okay? That's all we were doing here. Now this part, the negative 6, Bryce, what does this negative 6 tell me? You don't know? We've been talking about it. It's the y-intercept. This is y, Bryce. Let me tell you exactly why it's the y-intercept. When you're on the y-axis, what is x? 0, right? Well, if I were to substitute a 0 in for x, would there be anything here? 3 times 0 is 0, right? And if I were to substitute a 0 in for this x, 3 times 0 is 0, so I would get 0, negative 6. That's why. That's why this right here is your y-intercept, because it's when all the other x's are 0. Yes, Aaron?
So the axis of symmetry is 3 then? X equals positive 3?
The axis of symmetry is going to be in between your zeros.
So you can't tell just from that?
No, you can't tell just by looking at this what your axis of symmetry is. So I'm at 0, 6, 1, 2, 3, 4, 5, 6, negative 6. 1, 2, 3, 4, 5, 6, negative 6. Now I need to find my zeros. I have 1 0 here. This all is actually, when I'm graphing it, is all equal to 0. Where do I want to put this? Down here. Check this out. Let me take a picture. I'm just going to take a picture of this part right here. Let's move it down here. Yes. Yes. The x is always 0 on the y-intercept. Because you're not going over any at all. You're not going this way, you're not going this way. You're just going up and down on the y-axis. That's why it's 0. Okay, check this out, guys. This is actually, when I go to graph it, both of these are equal to 0. All right? So I have 3x plus 6 equal to 0. Or I have x minus 1 equal to 0. So that makes this one x equal to 1. And that makes this one, if I subtract 6 from both sides, divide each side by 3, I get x equal to negative 2. That's the formal way of finding these zeros. Or you could say, what's the difference between x and 1? 1. I don't want to know 3 x's, I just want to know 1 x, so I'm going to divide by 3. Right? Or I could have rewritten this, I could have pulled the 3 out and got x plus 2, x minus 1, and then I've got, I hate how this program does that, and then I know that my zeros are negative 2 and 1. Lots of different ways to look at it. Okay. Nope. Just the same. Because all this is basically telling me is it's kind of like my rate of change, which when you look at the standard form of the equation, doesn't it have a rate of change of 3? Right? I'm just pulling it out so I can understand my zeros a little bit more clearly. Chris? Yes. You need both of these terms, both of these forms in order to graph it. Unless you can see exactly, some of you are going to be able to just see that. Yeah, Kane? The trinomial? Yes. You can write it out. That's right. Right? You can do it either way. Yes. The Y-intercept? The zeros? Okay. So it's difficult for me to teach this part because there's so many different ways to look at it, right? Probably if you're still not understanding how to find the zeros, then you're just going to have to set each factor up to 0 and solve. Set each factor up to 0 and solve. See how I did it for this one? And found this. That was for this factor. I found my 0. And then for this one, I found my 0. So if you're still not understanding, remember how when we had absolute value? Where am I shifting on that? To the right 2. So where am I shifting to find this 0? To the right 1. And where am I shifting on this one? Well, I don't want to shift 3 times, right? You don't want to do 3 x's, I just want 1 x. So I would know I could divide the x's by 3. That's just how I do it. And then you get this. I think we just need to keep doing more. Okay? Just repetition is going to help with this. All right, so now that we've got all of our pieces to our puzzle, right? I know my zeros. My zeros, I found one of them. It's at negative 2. Because it's going to be, this in true form is really x minus negative 2, right? That's what makes x plus 2. Because we're always finding the difference between two things. So my 0 here is negative 2. And my 0 on this one is positive 1. So if I were to find my axis symmetry, it's in between those. So I would go over 1, and so my axis symmetry is actually right in between those. It's negative 1/2. So axis symmetry is negative 1/2. I've got all the pieces that I need because I know that that's symmetrical there. Bryce, is it getting better? The graphing part? Okay. I think the only part that's getting people stuck at this point is first the graphing and the zeros, right? So I think I can switch over to now factoring. I'll tell you right now, what are my zeros on this one? 1 is my 0. What's my 0 here? 3. Because if I were to divide both of these by 3, or if I were to factor out a 3, I would get x minus 3. So my 0 is 3. Right? No? It'll come. Light bulbs are starting to come on here and there a little bit. I don't feel the need to do this. I just divide both by 3, and that gives it to me. All right, so without even doing any of the math on this, I know that I have a 0 at 1 and a 0 at 3. So I know my axis of symmetry would be 2. Because it's right in between. Axis of symmetry, whoops, we're doing lines now. Axis of symmetry is 2. My y-intercept, how could I do that pretty easily without doing all of the hard work of coming up with this part? -9 times -1 is +9, which makes sense with my graph. 2 away, 2 away. What do I need to graph right now? We're sketching graphs. We're not actually graphing, we're sketching. What do I need in order to graph right now? What's the first thing I need? Y-intercept. What's the second thing I need? The zeros. What's the third thing I need? Axis of symmetry. Right? Those 3 things. Okay? First we do the y-intercept, then we find our zeros, then we find our axis of symmetry, and we're ready to graph. That's all we need. All right, so I'm going to come back. I really want to get to the factoring. What do I know? What's different about this graph? It's negative. What does that mean for the graph? It's going to be pointing down. What's the rate of change of this graph? It's 3, guys. Okay, check this out. This is why. It's a negative graph. I'm going to want to factor this with that negative out. Does that make sense? So I'm kind of going to ignore this guy right here. I'm going to ignore it as I do this math. I'm pretending like the negative's not there. The only thing the negative's telling me right now is that this graph's going to be pointing down. Okay, so I'm going to do the same thing I normally would do. 3x times x is 3x squared. 6 times -2 is -12. Okay, then I've got my 6x, and I've got my 3x times -2 is -6x. Correct? So I have a 0x here. Which works, and I'm going to tell you why in just 1 second. Okay, so what's going on here now, this is not my standard form. My standard form is actually here. Let's move these guys. I wish I wouldn't have hit this one until I started factoring. Oh well. Now I'm going to distribute that negative to get my standard form. Was it f of x? I don't remember. Equals negative 3x squared. I don't even have to worry about that because those cancel each other out. And I have negative times negative is a +12. There's my standard form. So my y-intercept is not actually -12, right? Because I have a negative out in front of it, it's +12. This one wasn't a good one to do. So soon. I wish I would have grabbed you guys a little bit more before I did this one. All right, where are my zeros? I know I've got one here at 2. I got to divide by 3. So let's rewrite this. If I were to pull out a 3, it would be -3 x plus 2 x minus 2. Let's make it a little bit further down. Negative 3, x plus 2, and x minus 2. What does that look like? Not a perfect square. It's called something different. I heard it. Difference of squares. Check this out. You guys ready? Okay, your mind might hurt a little bit for a second here. Okay, you ready? No, you're not ready? You're not ready to learn more? No. If I were to factor this, guys, look it. If I factor this, if I factor out a negative 3, what's left over? X squared and what? Minus 4. Isn't that the difference of 2 squares? Negative 3, x plus 2, x minus 2. All the forms are the same. They're all the same thing. Yay? Okay, so I really just need to know I have a 0 at 2 and negative 2. I also have, right here, it wouldn't have made sense if my y-intercept was at negative 12, because what's this graph have to look like again? Has to look like this. So no wonder it's going down, and then this, it's going like this. So what's my axis of symmetry? X equals 0. Okay. We got to go the other way. You guys ready for it? Yes, me. Why didn't I? Okay, say it again, loud. Do this. Here? You could have. Yeah. Because not everybody's understanding that. I'm saying it and some people are picking that up like that, and other people are going, what is she doing? It makes sense to me, but it's not making sense to everybody. You do that. That's what I do. Okay? Some of you are going to need to do this. Some of you are going to have to set these two up to 0 and just solve, because it's just not making sense to you. All right, I'm going to go backwards. They all relate, right? We're just going from one form to another, one form to another. So I'm going to do this one really quick. So I'm going to get that x out, just like before. So if I get that x out, I know I've got 2 times negative 5 is negative 10. I need to talk this up. And I have a negative 3. So what two numbers, when I multiply, I get negative 10, but when I add, I get 3? 5 and 2? So if I have a 5 and a 2, which one has to be negative in order to get the negative 3? The negative 5. So now I'm going to rewrite this guy. So when I rewrite it, it's going to be 2x squared. Instead of the negative 3x, I'm going to make it negative. Okay, now here's where we get some confusion. Negative 5 and 2. Would I write negative 5x plus 2? Or should I rewrite it 2 and negative 5? Do you see why I'm choosing to switch it? Because then I have my 2's together and my 5's together. Do you see that? The other way around, I wouldn't have factors together that would easily. So when you have a coefficient, you kind of have to think about which order you're going to put it in. You got to make sure that the factors match up together. So now I know that I can factor a 2x out of here. When I factor a 2x out of that, I get x. When I factor it out of this, I get 1. And when I factor out, this has got a negative now, so I got to consider a negative. When I take out a negative 5, I get x. And then this must be plus 1. Now they match. So my new two factors are x plus 1 and 2x minus 5. All right, so a few pieces of information. Bryce, I want you to help me out with this. A few pieces of information. What do I already know about this graph? What can you already tell me about this graph based on this equation right here? I know my y-intercept right here. My y-intercept is negative 5. Okay? 1, 2, 3, 4, 5. Y-intercept is 0, negative 5. I already have zeros here. This one's a little bit harder to factor out, right? Because there is no 2 in here. Now this is where that 1 made that idea that I've been going across where you just divide by 2. This one's easy. I can find my 0 here. It's just negative 1. So I know I have a 0 at negative 1. This one, to factor out a 2, factoring out a 2 of something, 2x minus 5. I could set it equal to 0. That's one way I could figure it out. Another way I could do it is factor out a 2, and then I have x, and then I'm like, I don't know how many 2's are in 5, right? That may not make sense to me. Or you can do it my way that I was saying originally, and just divide both of them by 2. It's 5 halves. How much is 5 halves? 2.5. Right? 5 halves is 2.5. If you don't like breaking it up like that, do 5 halves. 5 halves is 1 half, 2 halves, 3 halves, 4 halves, 5 halves. Okay? This one, the axis of symmetry, is not going to be as pretty. It's somewhere in the middle there. I'm not as concerned about that. I'm more concerned with you guys being able to, it's going to be like in the quarters. All right, I want to see if you guys can factor this. Let's record this one. First of all, what do I know for sure right off the bat? My y-intercept is 0, 25, right? Numbers, when I add, make 20, but when I multiply, get 100. 10 and 10? You're right, 10 and 10. 10 times 10 is 100, and 10 plus 10 is 20. Right? What? This is the best way. If you're having a hard time, this is the best way. Okay? Ready? You guys got all crazy on me right now. Yes. I can't hear her question. I don't understand what you're saying. The first 2 numbers. No, we're worried about all 3 of the numbers. Right now, I'm trying to find 2. I want to replace 20x with two terms that equal it. But in order to find it, I've got to consider how much I have to multiply to, which is 100. Right? I've got to figure out how much I need to multiply by to make 100, and I need to know how much I need to add to get 20x. So that's why I use this little, it's like just, it's kind of like a graphic on the side to kind of assist you. Yes. Yes. So this, you can always do that, constantly. You can multiply the last 2 and put it up, right? Here's how I would teach it in 8th grade, okay? I would say that I need the attic and the basement, where ax squared plus bx plus b, the b is my middle, right? And then the a and the c is the a and the c. Remember that? Okay, it doesn't matter. Not every teacher did that. So now I need everybody quiet. Okay, so what we're going to do is I'm going to take my 4x squared. I just split 20x into positive 10x and positive 10x plus 25. Now I'm going to start and factor this out. Is there a 4 in a 10? There's a 2, so I've got 2x, and then I'm left with 2x plus 5. And then what's in this one? A 5, so I'm going to factor out a 5, and I'm left with a 2x plus 5, and I say, oh look, I did it correctly because I have common factors there. So this equals, we'll do it here, 2x plus 5, and 2x plus 5 is left over. All right, this is what I want you to do for homework. You guys should there's really only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factoring problems. You guys should be able to do this. If you feel like you can't do it, you need to come after school. No. All right, let me go ahead and pause my recording. Who's also here? Oh, we had Carlos there. Okay, so we're done recording.